Like we've seen customers train and fine tune like 8B or the 13B model on their data, and it gives like better answers for their use case than like OpenAI's 4.0 model. Once you're going to get enough data, like that's why I would send everything to OpenAI, then it's definitely becomes better to just run an 8B or 13B model, fine tune it yourself. There's so much tooling in platforms like OpenPipe is a YC company that does it. Like they do it all through their platforms, so you don't have to even know anything.
You have to know about your own data, is what we always say. Like, the more you know about your own data, the more you can do in this whole new generative AI world. I love working with Michael and Cerebrium team. They are really great engineers. They have done a ton of really impressive work on cloud GPU stuff, including things that are very near and dear to all our hearts that we've talked about and we'll talk about more, like making cold starts very fast. And so I'm sure we'll have lots of questions to ask Michael. Last year, we worked together and built a fun demo that we called the world's fastest voice bot. And we called it that because after many years on Twitter, I finally learned how to write Twitter headlines that encouraged some posts to go viral. But it was, in fact, the world's fastest voice bot at that time. We showed that it was possible to do 500 millisecond voice-to-voice latency measured from the client by optimizing all the pieces of the stack and running the models close together and doing greedy inference on every transcription fragment. It really surprised people that was possible, and people would play with it and then post things like, it would be great if it supported interruptions. And I was like, you just played with it. You just interrupted it. But it actually shows how even a little less than a year ago, people did not believe that real voice AI conversational interactions were possible. And so when they tried a voice agent, even though it worked, sometimes it took their brains a little bit of time to catch up. And we've done a bunch of other things with Michael, and Michael's done a bunch of really innovative things that we've had no part in that I'm excited to hear updates about today. So, Michael, welcome. Thank you so much for joining us. And we will let Michael show us some stuff for a while, and then we'll curate some Q&A.
Thanks, guys. Happy to be here. Thanks, Quinn and the Daily team for letting us chat. I know me and Quinn have been working like, I think I chat to him more than I talk to my own mom, to be honest. So we've gotten pretty close. I'm just going to basically start off today. I want to run through just one, like what is Cerebrium or what do we do really well? I'm going to focus on low latency and voice applications. And the second thing is just two examples. One is basically the example that me and Quinn released that he spoke about, the world's fastest chatbot, where you have three separate services that all run locally in a cluster, and how what that looks like on Cerebrium, what latencies you're able to achieve, how much flexibility you get. And then the second one was actually what we released pretty recently with Pipecat, was an Ultravox example. And I'll get into what's special about Ultravox and what we liked about them. So basically what Cerebrium is, we're an infrastructure platform that makes it easy to build and scale data and AI workloads. So while Quinn mentioned it's GPUs, that can also be sometimes CPUs. So we have clients running everything from voice agents to like real-time digital replicas to LLMs to data processing jobs to regression machine learning problems, really just anything that you can think about that you're going to write in Python and that you can do across CPUs and GPUs. And the best way to think about us, if you want to get technical, is we're basically just a layer on top of data centers, and we provide two abstractions. So one is this like infrastructure optimization. So we take care of WebSockets, streaming. We've built our own context-aware file system, our own custom build kit. So we get cold starts down to 2 to 4 seconds. We're releasing GPU checkpointing in the next few months. And then obviously on the software layer, like I mentioned, it's batching, find, forget jobs, asynchronous things, streaming, etc. And like where we really like to play is really in performance and low latency use cases. DeepGround's a customer of ours. Tavis, Vapi runs a portion of their platform on us. Super Whispers, like a live transcription application where like I can speak and it can like fill my notes and things like that. And we helped them achieve, I think, less than 500 milliseconds in total latency for like 30-second voice recordings. Rhyme's a partner of ours, and then many others. So I just want to show everyone that we help companies that have pretty good brands that are super focused on latency, stability, and reliability and performance as our customers. And there's 6 main things that if these tick your buckets, then we think we're a good platform for you. One is just speed and latency is of utmost importance, which I think is why we do so many things with the daily team, because I feel like they're on the same path for that. 2 is just you can host CPU and GPU workloads. So typically with voice agents, for example, customers start off running voice agents where they're using Fireworks, OpenAI, but then as they scale, they might want better reliability, they want performance SLAs and response times, and so they host that right next to the voice application. One thing that we've released recently that's become a big unlock for a lot of our clients is multi-region support. So you can have one application that can run across regions. So we've got regions in the EU, in the US, and in India. And so for especially low latency applications, you can deploy once and it's available in all those areas, and we'll basically route, depending on where the user is making a request from, to the closest application. And it's also pretty great if you have clients that have GDPR requirements or data residency requirements. And again, we can extend that to other regions as well. Things like partnerships. And what we basically allow through that, I'll show you an example of it, is you're able to launch deepgram and rhymes models within Cerebrium. And what that means is we do intercluster routing between those different models, which means there's no network latency, one. And two is if you're serving an enterprise client or the client that has GDPR requirements, we can deploy all three of those models in the EU. And again, you get extremely low latency, or even in India. And we have a special partner with them, and we're bringing on other partners like PlayAI and Element and a few others. And then things like, I'll show you kind of code snippets of what it looks like to deploy in Cerebrium, but we don't have decorators, class design, a special way of writing applications. You just bring your Python code, we deploy it. So typically if you're using Fly.io or running stuff in GKE or AWS, it's very easy to migrate because you just have to add a file to your GitHub repo instead of just changing what your code looks like. So now that I've done the sales pitch, let's just jump into the code. I mentioned the two examples that I wanted to show today. So this is the first one, and this is what Quinn and I worked on when we did the world's fastest voice bot. And basically when it comes to latency, you just want everything to be co-located in the same cluster, because if it's doing things over the network, you're incurring a network latency depending on where they sit. And obviously many different providers can host their servers either in the EU or US East versus US West. And then that all adds different latency. I think even if you're in the same region, it's about 50 milliseconds. But if it's US to US West, it's then 120 milliseconds. And so how you can deploy this on Cerebrium is we basically package everything as a container. And I'll show you what that looks like. But here it's basically 4 separate containers. One is the Pipecat agent, which is just running on a CPU. And that's just what you guys should be pretty familiar with. And then we have, I guess you can think of these all as microservices. Our deepgram speech-to-text model, Llama is running our LLM, and then we can use Rhyme, or we can use the same deepgram instance over here, or PlayAI, or whatever else to run on the GPU on this side. Or you can even obviously use open source models for both of these elements as well. It really is up to you. Again, if it runs in Python, it can run on our platform. And what's pretty great about this setup is each of these are auto-scaling, which means deepgram, for example, can only take a certain number of concurrent connections, which is completely different based on the GPU you use to the one that Llama can take. And the same thing with Rhyme. But for companies that typically do something, let's say using deepgram for voice agents, maybe they want to do things like sentiment analysis on their voice agent calls. And again, that's coming from the deepgram service. Or they want to do a summarization of calls, and that's coming from Llama. So you can think of these as microservices that you can call independently from other parts of your application. So it's pretty nice how we just automatically auto-scale this based on the parameters you set. And I'll show how you manage auto-scaling on Cerebrium. But again, so this is all within this like Cerebrium cluster. However, each of these you can think of as individual containers that auto-scale to what you set it as. So what this basically looks like is you'll notice as a typical, I'm using Daily Rooms as an example just because it's easier to set up than Twilio. And what you can see here is we basically have a custom deepgram service. And what I've done is I've deployed basically the deepgram partner service. And this is literally all I have to do to deploy a deepgram partner service. So I'm specifying it's in US East 1. I need 4 CPUs, 32 gigabytes of RAM, and it runs on an A10. And I'm saying that this can take 150 concurrent conversations or connections at any one time. And that's basically as simple as auto-scaling happens. What replica concurrency means is we do this on a request basis, but you can, for other applications, set it to if you want it to be a CPU utilization or memory utilization concurrency metric. So that's how easy it is to get the deepgram instance running based on our partnership with them. With Llama itself, for those of you that are familiar with VLLM, we basically just launched an OpenAI compatible VLLM endpoint. So as you can see, this is just basic copy paste from the VLLM website. There's nothing special here. One thing about this Cerebrium syntax, like I said, is it's just basically Python code that we actually abstract around. For example, we turn every function into an endpoint that's accessible through an API call. And if you obviously don't want it to expose it to the public internet, you can just put an underscore in front of it, and that makes it private. So again, it's like we hope the learning curve is very low for a lot of our customers, which is why migration is pretty easy. And again, this is just basically chunking the results from VLLM, returning it in the OpenAI compatible format. So it's compatible with Pipecat's like SDK for OpenAI's endpoint. And again, here I just said I want it on L40. What's my RAM and replicas? How many min replicas am I running? What's the per packages that I'm doing? Again, pretty straightforward to get that up and running. And then lastly, just to see how it all ties together in a Pipecat agent. Once I've deployed those two services, again, they're like their own microservice, I can then do intercluster routing of the application. So you can get this in your dashboard, and I'm making a call directly to it. And I'm specifying here, I want to use the Nova 2 image. You can use the Nova 3 image because that's the latest one from DeepGram. And then here I was just using Cartesia. I just wanted to show you can swap these in and out, but you could change this to use DeepGram's Aura models over here. And then lastly, here's basically where I'm calling our Cerebrium deployed Llama model. And then to be honest, I think you guys have probably seen enough Pipecat demos on how the rest of the code looks like, but it's just creating a room, creating tokens, what's the messages that I append, and then what happens when a participant leaves or joins. So if I now quickly create an API request to this endpoint, I will join the call.
Hello, I'm Fastbot here to assist you quickly. What's on your mind?
Hey, can you tell me a funny joke?
Sorry, not yet. I'm just here to help.
Can you tell me a dad joke at least?
Why did the coffee file a police report? It got mugged.
That wasn't funny.
I'll try again. What do you call a fake noodle? An imposter.
So as you can see, I'm just going to mute it now so we can see what the latency looks like. So if I this is what the Cerebrium dashboard looks like. So again, I can see all my services. I can see what request counts are, success rates, average response times. So if I just go into my Pipecat agent and look at the logs, we can probably go through and see what we were experiencing. So Cartesia, 140 milliseconds, that's pretty standard. LLM, 430. And then I think with DeepGram, it shows different ones. Here it shows 446, but that's usually for late in the conversation. Whereas there's other ones where you can see here it's 0.5 milliseconds for the LLM. It really depends on how long the prompt gets. Yeah. So this is basically as you can see all the logs, but I don't know if it came across in the demo, but it was pretty quick to respond. Basically what we've seen for a lot of our clients is there's a couple reasons why they like it. One is you can deploy this across multiple regions, which is obviously great. So again, if you want to serve global clients, you can do low latency and don't have to adhere to latencies where servers aren't in the same region. 2, you can adhere to any data residency and compliance reasons. 3, and this is probably the biggest thing that we see with customers that scale, and I would typically recommend this architecture only if you're doing more than maybe 15,000 calls a day. The only reason why I say that is because that's the only time that maybe hosting your own LLM actually becomes effective in your unit economics compared to using something like OpenAI or the rest. And I would recommend slowly moving over other parts of it. So I would first probably launch my own DeepGram instance while using OpenAI and Cartesia. And then from there, maybe I would switch over my LLM. And typically where this is also very useful is when you're serving enterprise that have specific SLAs. So a lot of our clients, they need to guarantee under, let's say, a 1-second response time with voice to voice. And typically what we see is that, I'm sure many of you have noticed this, is sometimes OpenAI can respond in 300 milliseconds and sometimes it can respond in 1.5 seconds. And for our enterprise clients or clients that have enterprise clients, that's just unacceptable for them. So by hosting your own LLM, 1, you can get unit economics pretty low. And then 2 is you can guarantee SLAs because you're not getting affected by traffic from other users on your server. I think also with this setup at scale, again, the lowest we've seen someone get their total cost is about 4 cents a minute, which is pretty incredible. So that's the self-hosting microservice route. I think that's great if your application is very verbose. Like I said, you're doing global, you're doing multiple regions, you're hitting enterprise. A kind of different architecture, but at the same time, it's also got its own benefits. Is using something like Ultravox, where you actually put it all in one model. And Ultravox is basically a speech-to-text and LLM in one model. They're eventually working their way up to do the full speech-to-speech pipeline. They haven't done that yet. And what's pretty great about it is that it's open source. So you can actually train based on maybe your prompts that you want or your languages or things like that. And they use Whisper and Llama as their internal models that they've basically stitched together. And you'll see that the latency is pretty great. And the way that we design this is we put Pipecat and Ultravox basically on the same container itself. And so if you make the resources and the CPU and GPU resources big enough, you can have multiple users hit the same instance. And then that can obviously auto scale based on that. So I think our one on an H100, it took about I think it was about 12 or 18 concurrent conversations at a time, which is pretty good, and it worked pretty nicely. To show you what this looks like from a code perspective is it's pretty similar. There's only one key difference really is we basically instantiate the Ultravox model, and here we're using just the AP one at the top of our file. The reason why we do it at the top of the file is obviously there's a load time associated to loading the Ultravox model into the GPU memory. And the way Cerebrium works is when a container is starting up, we basically run all this code at the top to basically initialize your container. And then every time a request comes in, it skips all of this top stuff and just comes in, let's say, at the run endpoint. And so basically there's no latency, which is very popular. And another feature that you can join this with on Cerebrium is because this takes, I think, about 10 seconds to load in, we have this metric called basically in our autoscaling called a scaling buffer. And it's exactly what it is, a buffer. And so basically every time 80% of my requests are busy, it will scale up a new instance. So what that means is obviously when one request comes in, it's automatically going to start a new request so that any overflow can go up and then obviously it can scale back down. So if I make this 10, it means that when this hits 8 out of the 10 connections to my instance, Cerebrium is going to start another instance for me so that when I go to 12 connections, then customers don't experience that lag and latency. So that's how you can use a scaling buffer. And then, yeah, I think everything else is pretty much the same. So now to show you a demo, I think this one was actually faster than the previous 3 that I showed. And so if I just generate the request for this again. Hey, how are you doing?
I'm doing well. Thank you for asking. I'm a large language model, so I don't have emotions or feelings like humans do, but I'm fine. It seems like you're trying to start a conversation, but you haven't provided much context. What's on your mind? Do you have a specific topic you'd like to discuss?
Typically what we saw with this one was the LLM actually generated in 200 milliseconds through the speech, which is pretty great. And then basically the text-to-speech was about 140, which is from Cortesia still. And then the other networking parts, because everything's local, is also pretty low. And yeah, so this gets to about a total of 540 as well. And again, the benefits here is that it's open source. You can train on different languages. You can again post in enterprises like it because it's open source, things like that. So Ultravox is definitely someone I would also watch. We're also chatting to them. They also have a hosted product, which they're looking to host a portion on us. And then, yeah, I think that's 2 demos. Sorry about that last one, but hopefully you guys have some questions and happy to answer them. One final thing to say is just maybe before we get into questions is everything I spoke about, we have GitHub repos. We typically post everything we do with Quinn and Daly and the Pipecat guys in our GitHub repos, but you can find that on our website or our docs. There's like a link to our GitHub repo. So these 2 examples, code's all there. It should just be simple deploying, and then you guys can start playing with it, editing it to your use case.
I think there's a bucket of questions that's in general, like how do you advise people who are thinking about hosting their own models about the cost specifically? There are other reasons you might want to host your own models besides cost, but what does the cost look like? How do you start thinking about the cost? You said 15,000 calls a day is a good rule of thumb for traffic for hosting your own LLM. Do you think of hosting your own LLM as more expensive or as more expensive up to a certain traffic volume and less expensive? What's the shape of the cost problem?
It's such a tough one to answer because it really depends on the sophistication of the use case. Like for customers who are, let's say, doing restaurant bookings, you're probably not dealing with anything complex. Whereas with like healthcare, like that's super complex. And so like there you need to run a Llama 70B, which needs like an A100. Whereas restaurants, you could run a Llama 70B. So an H100, for example, I mean, is maybe $5 or something along there every hour. Whereas like an A100 is maybe like $2 an hour. Also, with the Llama 70B, for example, you're limited by concurrency for low latency. I think the best we got for a client was we maybe got like 50 concurrent connections and they're paying like maybe $100 a month. Don't quote me on those numbers, but that's basically what you're looking at. So it really depends first on the model that you want to select and the GPU you need to run it. So if you can run like an 8B, I think you can do it pretty quickly and like pretty early in your journey where you can guarantee latency. As soon as you go Llama 70B, because you want high concurrency and low latency, I think that really only works at scale. Again, there are frameworks coming out that are making it quicker and quicker all the time. So you could look at that. So that's my thing on the LLM. That's because that is the quickest speed up that we see, and you get less affected because OpenAI just seems the most variable. In terms of DeepGram and like text to speech, look, I think Cortesia and there's a few others now, like Rhyme's also gone pretty good. They're doing like 150 milliseconds. Like the fastest that we've seen is if you use like Rhyme on-prem on us, it gets to about 80 milliseconds time to first token. Like 50 seconds is probably not worth managing it yourself unless you're doing like enterprise deployments. You're doing different regions. So for example, like Rime, their servers are only located in the US. So if you're in the EU and the like India or Asia region or Australia, then it's probably best to host your models pretty early on. So to sum it all up, I would always recommend looking at the text to speech and speech to text parts first if you have low volumes, just because those are going to be the cheapest, and at least you can save 200-300 milliseconds in like your time to first token. And then the LLM, I would only do if you're going to run like an 8B model or something a lot smaller. But if you're running like DeepSeek or Llama 70B, I would wait until you had a lot more scale, because you need an H100 to run those on H200. And those are pretty expensive, and you have capacity limits and quotas. We don't have capacity limits and quotas, but it does get expensive.
Do you have a rough rule of thumb for an H100 for a month so people can just think about those blocks of spend?
We have a pricing calculator on our website. We are reducing prices actually by the 1st of June, if anyone's interested. But I would say an H100 basic costs, so 1 cent a second. I would say you're looking at definitely like $1,000 or plus.
And that's like for Llama 3 370B, that's 50
So
concurrents?
it looks like it's $2,600.
$2,500, yeah. Okay.
Yeah.
And that's 50 concurrents on the LLM for Llama 70B on H100, yeah.
Yeah, but it's more because with concurrency, it's a time to first token trade-off, because if you wanted to still hit like the 300 millisecond mark, which I think was what we were always aiming for, you can't go much higher. So that's probably the most. You can go higher, but then you're going to sacrifice that latency. Again, another thing that also depends there is like how big are your prompts? If your prompts are like 8,000 tokens or like 16,000 tokens, that's going to lower the concurrency. And so these are all the things that you need to play with. So the advice that we give to any company that like starts using us is just come to us and actually just use all the APIs, but deploy Pipecat, and you can set it as a nice foundation. Then you can swap out the one part of the speech to text model, the section on the one side or on the other side. And then once you start getting enough data that you're sending to OpenAI, you can really understand what your use case looks like. Like how complex is it? How big is my input and output tokens that I'm generating? That will inform what's my concurrency length, things like that.
This is true for so many things. It's true for cost estimation. It's true for being able to run evals. If once you have data, like if you're actually storing the data, and it depends on what your use case is and what your agreements with your customers are, but if you can store historical data, you can iterate on quality, cost, a bunch of other things. So you're aiming for 300 millisecond CTFT from the LLM piece. Do you see real world uses of the 8B models? Like you showed the Ultravox 8B model. What are some real world uses that can use that small a model in the voice AI world?
Sometimes just setting appointments, getting basic data. Sometimes people do it just to do summaries. So one thing that people do, which is pretty interesting, is, like I mentioned, the prompt length becomes an issue. We've seen customers that use a smaller model to summarize the existing context length into something much smaller to improve the inference speed. And so use stuff like that, things like general questions. So we also see people do like routing. So like they would route a complex model for a complex query, and they run this like simple classifier, which is like even a CPU-based classifier. It's very easy. And then they route an 8B model for something that's like simple versus complex.
Yeah, for my part, and this stuff is always changing, but I'm skeptical about using a small model for the core conversational loop for general purpose voice AI, but definitely doing route. Like if you have a sophisticated enough setup that you've evolved it over time where you know what some of those queries are likely to be, then routing to smaller models is really effective.
We've seen one thing on that is we've seen, again, as you add data, like we've seen customers train and fine tune like 8B or the 13B model on their data, and it gives like better answers for their use case than like OpenAI's 4.0 model. Yeah, so I just feel like once you're going to get enough data, like that's why I would send everything to OpenAI, then it definitely becomes better to just run an 8B or 13B model, fine tune it yourself. There's so much tooling in platforms, like OpenPipe is a YC company that does it. They're pretty great. I think they're doing a session with you as well on this course.
That is just what I was going to call out. Friday fine-tuning models with OpenPipe is a session this week. So we will.
Yeah, so they get like phenomenal performance. Like they do it all through their platforms. So you didn't have to even know anything.
You have to know about your own data, is what we always say. Like the more you know about your own data, the more you can do in this whole new generative AI world. So lots and lots of questions about DeepGram. One, to kick off, do you price and package DeepGram as you're reselling it, or do your customers have to have a commercial DeepGram license?
Yeah, so they do have to have a commercial Deepgram license. But the thing is, what we found is like one is Deepgram's customers are mostly coming from the like India, EU region, because again, everything's in like the US. And so we are looking, I probably shouldn't say this out loud, but we are exploring hosting their stuff in the EU for them and in India to open up those markets. So we'll see if it actually happens, but then hopefully for those customers that are there, which should really lower the latency that they're going to receive in those countries. But yeah, you have to have a Deepgram enterprise contract, which I think is 10K a year. And then, yeah, with us, you just pay the GPU cost, which I think is like $2.15 an hour. And that can do maybe 150 to 200 connections.
So that gives you a rule of thumb about how to think about Deepgram. It really is easy to deploy Deepgram on the Cerebrium. I've done it a bunch of times.
All our partners are different. So, for example, Rhyme, they don't require an enterprise contract. You just have to bring your API key and then you have whatever pay-as-you-go plan with Rhyme. And then with some of the other partners we're bringing on board, we're going to see if you need to have an enterprise plan or not. So it's still up to for discussion.
There was a question about where most of your customers are. Are most of your customers in the US or outside the US?
Most of them are in the US. However, we're helping them expand into the EU, and India has been a massive region for us. And so, yeah, I would say like most of them are here, but they're looking to all expand their operations now.
And there was a question about back to the Ultravox demo. So what's the container structure for the Ultravox demo?
So basically, Pipecat is running with Ultravox in one container. So we're running it on a GPU, but like we're running obviously the Pipecat portion on the CPU, and then obviously Ultravox is on, I mean, it's using both CPU and GPU, but yeah, on that side. And so basically it's just one container that's spinning up, and each container, I just said it because I think I had it on an A10, is I think you can take 8 concurrent connections. But if you put on like an H100, I could take, if it's a Llama 70B, it could take maybe like 25, 30. So yeah, it really just depends.
And what in that demo you were using Cartesia public API endpoint for the voice output?
Yeah. Again, you could host something local. I just kind of wanted to show like, obviously Pipecat's very versatile, so you can really just plug and play whatever you need, and you can fall back if anything's down or things like that.
Somebody in the Discord is asking about a use case where people tend to stay connected and talk to extended periods of time.
Yes, the two use cases that we do is one is this is related but also different, but it's just for voice AI is quite a big thing. Is on Cerebrium, we want our customers to like constantly deploy if they ever figure out bugs or want to release new versions. And so one big thing we do is we persist all connections. So if you have 1,000 customers that are in calls and you deploy a new version, we'll keep the old conversations running until those calls end, and then only the new version will apply to all the new calls. And then, yeah, in terms of the, sorry, what was your question again? Actually, I forgot.
Really long running connections.
We go up to 24 hours in long running tasks. So we have these abstractions where you can basically, it's a fire and forget job is what we call it. So you can basically run in the background. It keeps running until you have some ending condition, like you return. And then a thing that you can basically add is we have these automatic webhook endpoints that are built in. So we can notify you when, you can obviously implement this in your code as well, but some of our customers say it's like cumbersome. So you can also notify an endpoint once a call is done, and you can send it a bunch of information about the call length, the customer, what was the end result, whatever the case may be. So we have that built in as well.
And one piece of this question, is that a good cost shape for Cerebrium? And I would say yes, because one of the things we see with the very long running connection, talking to a bot for a very long time, is the cost per user is higher if you're using the inference services because you're paying per token. But maybe you can model it better if you're using Cerebrium because the cost per user doesn't really change that much. It's the concurrent users that you have to plan for. So a user who talks to you all the time doesn't cost you any more money as long as that's below your sort of concurrent user cap. At least that's how I think about it.
That's also just like the other use case I gave. You can use those microservices in many different ways. So yes, I can talk to my like Llama endpoint for conversations, but I can also use my Llama endpoint to summarize a different part of my application. And so again, like there I'm utilizing my GPU a lot more than just focusing on one voice AI use case. So we also see like maybe that's back to the cost question is like if you can create these microservices and utilize them across multiple parts of your application, you can then offset that cost and it becomes then pretty worthwhile.
Talk a little more about those partnerships and how the intercluster routing works, because I actually don't understand that.
Just basically what I showed with the 3 model example is we're not going and making requests over the internet. So Deepgram's hosting their model inside Cerebrium. And so you're making a request directly to Deepgram's model inside the cluster.
Oh, I see. Even if you're using the public Deepgram API, what you're going to get routed to is it?
So this is when you have to go to that partnership with Deepgram. And so then Deepgram gives you a license key, and that's what you can deploy on Cerebrium.
Okay.
And it's running there, and then you can just basically do everything inter-cluster. So I don't know if Modal supports that inter-cluster routing, but what's nice is then there's no network latency. So I think the response time between our like containers is basically like single-digit milliseconds, if even that. And so that's how partnerships work. So over the next 2 months, you should see all the big players in the voice space become partners. So regardless of who you provide, like whether it's 11 Labs or Play AI or Element or whoever else, Assembly AI, hopefully they'll all be on our platform as partners. But yeah, in terms of the difference between us, I would say that's probably it.
Somebody's asking whether there's a sort of VPC or on-prem story with Cerebrium.
There is not, but it is coming in Q3. Same thing, you can basically I'll show you our roadmap, but yeah, basically Q3, you'll be able to deploy in your own VPC is number one, which is pretty great for anyone that's got like AWS credits or any other sort of credits. And then Q4, we will allow you to deploy in your customer's VPC. So we'll take care of all security compliance, resources, run optimized runtime. So what's great about that is you can have one version of your application. It can be your cloud hosted version, but you can run it in the cloud or you can run it in their cloud. So hopefully that should unlock startups to go straight into enterprise from day one. And yeah, we're working with a bunch of security people to pass all like the Cisco requirements, which has been pretty painful.
Yes. Somebody's asking whether, let me get it right. Is it possible to spin up a container with a Pipecat bot on Cerebrium using fast API endpoints hosted in my own EC2 that report back to that fast API using a webhook?
Yeah, I mean, we're just deploying the Python code. So if it can work in Python, it can work. So again, you can expose any endpoint or fast API on Cerebrium, and you can generate code that can hit those endpoints or come back. Yeah.
Yeah, let us know if we didn't understand the question correctly, but it seems like that should just work. Modulo access controls on the EC2 side, which sure, it's its own thing to set up.
And that brings up, I think, a more fundamental discussion / opinion conversation, maybe like fundamental to Pipecat. And I hate to make this a bit of a Pipecat commercial or whatever, but it is what it is. We're getting a lot of questions about it. The fundamental thing with Pipecat is that you need to have something that decides, essentially you have a user that wants to talk to a bot. There are typically two things that happen. Step one is that user makes a request to some kind of API that you're running that says, hey, can you give me a bot instance? And then but it is up to the infrastructure that you're using to figure out how to get a bot instance, give it back to that user so that user can connect directly to that bot instance and to have a conversation. And it's a problem that we're trying to solve with Pipecat Cloud. But I think perhaps more interestingly for this conversation, with Cerebrium, is it better for me to think about deploying a specific, like different instance type or something that is just doing that kind of front end fast API coordination? Or is that something where it's like, I'm already running one machine that's going to serve up to a certain number of concurrent users? Is it better suited to running that API front end, like in the same machine or whatever?
Oh, I would say probably not. It's probably the same reason why we had 3 different services there is because a fast API has different concurrency limitations to a Pipecat bot. So I think like a Pipecat bot, I forgot what me and Quinn always said, but I think it's like 0.5 CPUs and 1 gigabyte of memory per Pipecat instance or something like that. Whereas like a fast API, I mean, you can scale to 1,000 of those with that like same thing. So what I would do is I would deploy a separate like fast API if that's like what you want your application to interact with. And again, people host APIs and that's all the time that interacts with like the front end. And then I would run your Pipecat agent separately just because it has different concurrency limitations.
Well, yeah, that's what I figured. I just wanted to call that out in case there's some follow-up questions about that.
And similarly, something that's been on my mind is as we've fleshed out Pipecat Cloud, I would like to build that intercluster routing with Cerebrium so that you could flexibly host some services on Cerebrium, even if you're running your CPU bot on Pipecat Cloud for whatever reason. You can also obviously run the CPU stuff on Cerebrium. It's good to have options.
We wouldn't be able to do intercluster because you would be across the internet for us.
Oh, sorry, inter-AZ, you're like on it.
Oh, like that. Yeah.
Yep, totally. I think we might have got through all the questions.
I've got one more I can throw in there that might be interesting. So I'm thinking about a use case We saw a presentation again. Sorry, I'm just going to be full on Pipecat show for a second. We saw a great presentation at AI Engineer in New York about SuperDial and the work that they're doing. And one of the things that their voice bots do is they deal with a lot of like just the most banal conversations you can think of with insurance companies where it's like, I need to verify the status of this claim. And step one of that process involves an agent essentially sitting on hold for something like 45 minutes or whatever. It's replacing a person having to sit there on hold for 45 minutes and wait for an insurance person to answer the phone. And we had an interesting conversation this morning with Cartesia about concurrency and how they think about concurrency, because Cartesia has a limitation of up to 15 concurrent sessions. But it turns out behind the scenes, it's a lot more complicated for them, where like it actually matters how much speech is being generated moment to moment with each of those sessions. So when you hear 15 concurrent sessions, you actually get a lot more concurrency than that. And what I'm wondering is, when you look at concurrency use cases for Pipecat on Cerebrium, it sounds like a use case like this, where if you have a long time where you know that this bot is having to just wait a long time before it actually starts like running a lot of LLM inference and stuff, if there are advantages to running on somewhere like Cerebrium where you could say, I can actually handle a lot more scaling on one particular instance, like out of the box, like you said, typically it's, what is it, half a vCPU and 1 GB of RAM. If you know that a lot of your calls are just mindlessly sitting on hold, can you get away with even more concurrency when you have lower level control over exactly how you define your concurrency and that kind of thing?
Yeah, so we see both things, and it depends on how like this goes quite deep in the processing. I think I was talking to Alexi and Quinn about this because like I think a lot of our customers who run more complicated Pipecat setups can't get away with the 0.5 CPU and the 1 GB memory. They need a lot more. And so it very much depends. But that's also why I was saying like having the different services, if your application can utilize them in many different ways, you can make up for it. And I would say rather be safe with the concurrency, because let's say for the LLM example, if your prompts are suddenly so much larger, then it's going to actually just run into a memory issue. But if it's so much lower, you don't have a utilization. So only when you have more data can you really see what your system looks like. And again, it depends on use cases. Like some customers would rather waste it because they want reliability versus speed, for example. And so yeah, with us, it's like we got that in your hands, to be honest. It makes our lives easier. So you need to tell us like what are the concurrency settings, when to scale up, when to scale down. But that's where that concurrency like scaling buffer comes pretty useful. So for example, in Cartesia's use case, they could say, okay, cool, we can take 15 concurrent connections, but maybe they don't want to actually do it like that. They said, look, we want to monitor the GPU memory, that when that gets to 80%, start up a new instance and then direct more traffic that way. And that's what they can do with that scaling buffer concurrency utilization parameter in our TOML file.
Do you typically use the prefix caching in VLLM? Does that help with latency as the multi-turn conversation creates a longer context?
It does, yeah. So we do use that. We also use quantization. There's also this thing, I forgot what the name is in VLLM, but you can basically run a smaller model in VLLM as a pre-model that it basically pre-guesses the tokens, and the bigger model actually just confirms it, and actually it's a pretty big setup and speed up.
It's the speculative decoding stuff in VLLM?
Yeah. So that works pretty well. But we also, even with VLLM, and like VLLM works great in some use cases, but sometimes we've seen TensorRT and SGLang work better in other use cases. So there's a lot of experimentation that goes on.
And Neil in the Discord is asking how you started Cerebrium. What's the origin story?
Yeah, I had a previous e-commerce company that was growing pretty fast. We scaled from $150,000 a month in revenue to $250 a day in less than 7 months. And we hired 450 people in 4 weeks. And basically, like, e-commerce is a game about volumes and low margins. And so we tried to do machine learning, and it was like the worst experience I've ever had as an engineer. Tooling was fragmented, talent didn't exist. Some of the stuff we did, the unit economics didn't work in production. But we had these 3 use cases where it actually just worked: inventory forecasting, upselling and cross-selling and recommendations. And it put our company on like a different trajectory, increased revenue and everything. And we were like, we didn't eventually got acquired, but when we got acquired, me and my lead engineer were like, what if we can make machine learning more accessible to companies? What would companies look like? This was in end of 21. And now there's companies with 30 people that are doing $100 million. So clearly that's what they look like if they can do machine learning a lot earlier. So yeah, it's been pretty great so far.
That's great. I think we're pretty much at time. Did we miss anything, Chad?
I think this is probably a good natural stopping point.
Michael, thank you. This was awesome.
No, glad I got up. And yeah, people can join our Discord. They can reach me on email, but I'm sure you'll put me in touch. Yeah, happy to answer any questions.
See everybody soon.
Cool. Cheers.